Hello students, let's take a look at a classic problem type in thermodynamics. This type of problem is known as the boiling water model. In fact, you can use the same method to explain the melting ice model as well. For this kind of problem, there are two key concepts involved. For example, in this question, two things are important. One is the condition for water to boil. There should be two. So everyone please write down the conditions for water to boil. The first is that it must reach the corresponding temperature, reach the boiling point. Then the second is that it must continuously absorb heat. When both of these conditions are met, the requirements for boiling are fulfilled and our liquid will start to boil. Now, regarding the continuous absorption of heat, you need to pay attention to something called the temperature difference. If we want heat absorption or release to occur, there must be a temperature difference. Between objects at the same temperature, there will be no transfer of heat. Alright, with this preparation, let's take a closer look at this problem, as shown in the figure, in an open glass bottle. In glass bottle A, there is an appropriate amount of water. Essentially, it is floated in a water trough, and then another identical open empty glass bottle is placed upside down, as shown in the figure. After that, according to the trough, we fix the position in the water. Next, as indicated, we heat the water in the trough until it boils. At this point, let's analyze the situation step by step. First, for bottle A and for bottle B as well, they are both connected to the atmosphere, so the air pressure above them is atmospheric pressure. Under atmospheric pressure, the boiling point of water should be 100 degrees Celsius, and outside this water, its boiling point should also be just over 100 degrees Celsius. Here, let me mark 100 degrees Celsius. So even though we're using this alcohol lamp to heat and cause heat conduction, gradually, the water in the outer water bath will reach its boiling point. And because the temperature of the liquid outside the alcohol lamp is higher than the boiling point of water, it will continuously transfer heat to the water in the water bath. So for the water in the water bath, it will reach its boiling point and continue to absorb heat, so the water inside will definitely boil. Then a few days later, as the ambient temperature continues to rise, the temperature of the water inside container A will also increase. Now, as it rises, can it reach 119 degrees? Well, as time goes by, it can reach 100 degrees Celsius. It can reach 100 degrees Celsius. So reaching the boiling point is not a problem for container A. But can we keep heating it continuously? So as time progresses, can the temperature inside container A reach 100 degrees? After that, the outside temperature is 100 degrees. Since it's boiling, the temperature remains steady at 100 Celsius. The water in container A is also at 100 degrees, so now the two temperatures are exactly the same. Will heat transfer still occur? Very good, it won't. That's clear. If this condition isn't met, if even one of the conditions isn't satisfied, then boiling won't occur at this point. Therefore, container A will not boil. So statement A is problematic. Container A can reach 100 degrees, but there will be no heat transfer. So the water inside container A cannot boil. It cannot boil. Alright, now let's take a look at container B. For container B, it's the same principle. As time goes on, the temperature of the water inside B can also reach 100 degrees Celsius, but you need to pay attention to this. Put a question mark here. At this point for container B, is its boiling point still at the usual depth? No, it's not. As the temperature rises, the water will evaporate, right? So the internal gas pressure inside will increase, meaning it will be greater than atmospheric pressure. If the internal pressure is greater than atmospheric pressure, then the boiling point of the water should also be higher than 100 degrees Celsius. So in this case, it should be higher than 100 degrees Celsius. It faces a problem. It faces a problem, which is that the temperature of the external water bath is maintained at 100 degrees Celsius. Over time, as heat transfer occurs, the water inside your bottle will reach 100 degrees Celsius, but now, through analysis, we find that in this closed environment, the internal pressure is greater than atmospheric pressure, which leads to the boiling point of the water in bottle B being higher than 100 degrees Celsius. So what does that mean? When your temperature reaches 100 degrees Celsius and stays there, the temperature of the water hasn't even reached its boiling point. So for bottle B, the first condition is not met. Since the first condition is not met, the subsequent point in the process also won't be met. Therefore, for bottle B, neither of the two conditions is satisfied, so it definitely won't happen either. So here, our bottle B also does not boil. Everyone should choose option 4D. As for our analysis of bottle A, it's actually a typical problem within the scope of the high school entrance exam. The analysis for bottle B goes a step further, doesn't it? Alright, so we've finished analyzing this classic problem we've studied here. You can use this method and these conditions to analyze and see how we should approach the analysis for the main and secondary points. Okay? Alright, that's it for this question. Bye-bye.